So when we solve linear equality in two variables, the solution set is the set of all of the ordered pairs that will make the inequality true. So again, linear equality in two variables, it's related to like a linear equation in two variables, which is just write y equals mx plus b. So let's just determine, let's see if we can decide if a given point is in the solution set. So our inequality, y is greater than 4x minus 1. Is the point 0, 0 in that solution set? Well, I don't know. So the way we see is, right, we plug in the value. So 0 in for the y. So remember, it's x comma y. So we're going to check. Is 0, the y0, greater than 4 times the 0 that goes in for the x minus 1? I don't know. Let's see, 0, is that greater? 4 times 0 is 0, minus 1, negative 1. Is 0 greater than negative 1? It is. So this would be a yes. It is in the solution set. Let's check the next one. Is the point negative 2, 1 in the solution set? So again, we're going to plug, right? The negative 2 goes in for the x, the 1 goes in for the y. So is 1 greater than 4 times negative 2 minus 1? Let's see, is 1 greater than negative 8 minus 1? What is that, negative 9? Is 1 greater than negative 9? It is. So there's another point that's in the solution set. How about that last one? So if y is negative 3, is that greater than 4 times 1 minus 1? Is negative 3 greater than, what do I have? 4 times 1 is 4 minus 1, 3. Is negative 3 greater than 3? It isn't. So that's a no. So we found 2 points that are in that solution set. Okay, why don't you try the next one? Right, so my inequality, 2x minus 5y, is greater than or equal to 1. So check the origin. So is 0, 2 times 0 is 0, minus 0, 5 times 0 is 0, greater than or equal to 1. Is 0 greater than or equal to 1? It is not. So that's a no. The origin is not in this solution set. How about the point 4, 1? Is 2 times 4, get those in the right order, minus 5 times 1, greater than or equal to 1. So 2 times 4 is 8, minus 5, that's a 3. Is 3 greater than or equal to 1? It is. So that is in the solution set. And how about that last one, 4, 5? Is that in the solution set? So again, 2 times 4 goes in for the x. We're just checking, does it make the inequality true? If it does, it's in the solution set. So 2 times 4 is 8, minus 25. Well, what's that, negative 17? That is not greater than 1. So that's another no. So this one, I only had one of the points that was a solution set. Okay. Now, right, we wouldn't want to just guess and check every single ordered pair that's out there to see if it was in the solution set. So instead, what we're going to do is we're going to graph the related linear function, right, the related linear equation, and then we'll just determine which side of the line contains the solution set. Okay, the shaded graph is the solution set. That's how we indicate it. Okay. Now, just a little note, if your inequality is a less than or greater than, then we do a dotted line for the graph. If it's the less than or equal to, greater than or equal to, then we're going to do a solid line. Okay, so right now, let's start with graphing the solution set of y is greater than 2/3 x minus 3. Okay, so we start by graphing the line y equals 2/3 x minus 3, and we're going to use a dotted line, right, because the inequality, right, it doesn't have the or equal to. So I'm going to start at negative 3. I'm going to count off a slope of 2/3, so up 2 over 3, up 2 over 3. And I've got a note card here I'll use for a straight edge. So dot that line. I'm not a great line daughter. Keep going. Okay, now, how do we decide which side we're going to shade on? Well, there are a couple of different ways. So one, if you have the y by itself, you can just sort of reason your way through it. So you want the y's that are greater than this line. So the y's that are greater than that line are the ones that are above it. So we would actually shade above that line. That's where the solution set is. Now, an alternate way to do it, if you're just like, oh gosh, I don't know if I'll think of it that way, is you can just choose a point that's for sure on one side of the line or the other. So for instance, on this line here, we could check the origin. It's definitely on the right above / left side of that line. So if a point makes the inequality true, then all of the points on that side would make it true. So if 0, 0 makes my inequality true, then I would know to shade this side. So we'll just check, even though we already know we've already shaded. So let's just see. So 0, 0 is y0 greater than 2/3 times x0 minus 3. So is 0 greater than -3? It is. So since the origin is in the solution set, all of the points on that side are in the solution set. Okay, let's do the next one. So find the solution set. So 3x plus 2y less than or equal to 12. So again, we're going to graph the corresponding line, and we'll do a solid line because it has the or equal to. So I'm going to do the intercept method. So let's see. So cover up. So for the x-intercept, y is 0. So that term's gone. So my x is 4. And the y-intercept, x is 0. So that would be y is 6. So there's my line, or my 2 points. And we'll graph that, connect them in graph. So for this one, and I write my solid line, put arrows on it if you want. I'll do the check with the point, right? So for sure, the point 1, 1 is below that line. So if 1, 1 makes my inequality true, then all of the points on that side make it true. If 1, 1 doesn't, then probably I'm on the other side. I'll still take a point to check and make sure, but that's how it's usually going to work. So we're going to check the point 1, 1. If that's in my solution set, oh, 1, Angela, then all of the points that are in the same side as that point are also. So 3 times 1 plus 2 times 1, so is 5 less than or equal to 12? It is, so I chose the side that had the solution set, so it's all of those points. Okay, so before we're done, I just want to do a quick little review of some of the translations you'll want to know. So y is at least 3. So at least means 3 is included, but it's 3 or bigger. So that is y is greater than or equal to 3. So at least greater than or equal to. Versus y is more than 3. So that means it can't be 3. It's actually more than 3. So that would be y is greater than 3. Y is less than 3. So y is less than 3. It can't be 3. It has to be something smaller. Y is no more than 3. No more than 3 means it's 3 or less. 3 or less, right? Y is less than or equal to 3. And how about y is at most 3? So 3 is the biggest it can be. It's at most 3, so it has to be less than or equal to 3. So there were a lot of less thans in there. Okay, so just some, right, you want to be careful with those words.